In the last session, we have seen what is meant by cumulative distributed function. In today's session, we will see different properties of cumulative distribution function. What is CDF? Its applications are all extremely important. The first property of CDF is that it is bounded between 0 and 1. The maximum value is 1 and the minimum value is 0. The second property of CDF is a monotone increasing function. Cumulative distribution function is a monotone increasing function of x. Limit fx equal to 0 when x tends to infinity. That means that x tends to minus infinity. That means that the minimum value when x goes to minus infinity, fx of x, CDF of x will be 0, and when x tends to plus infinity, fx of x will be equal to 1. That means that the highest value that a CDF function can take is 1 and the lowest value that it can take is 0. And the next property is that fx of x is a continuous function, and continuous function from right. Say limit any e tends to 0, fx of x plus e is equal to fx of x. You can get a direct question in your exams. List the properties of cumulative distribution function. It could be a direct question in your exam. Shall I go to next? Next property, probability of x less than a and x less than or equal to b and greater than or equal to a. Probability of x between two values a and b will be equal to fx of b minus fx of a. Similarly, p of x is equal to a will be equal to fx of a minus fx of a conjugate. You can note that you have cumulative distribution function and probability distribution function both plotted in this. Probability density function PDF of a random variable. Now you can see that probability density function PDF is the derivative of fx of x. That means that fx of x will be always continuous and differentiable. Probability density function PDF is always continuous and differentiable. It applies to continuous random variables. So you should understand the difference between discrete and continuous random variables. So like the properties of CDF, we have to write the properties of PDF also. So PDF is non-negative, that means it can have 0 or all numbers greater than 0. F of x is always fx of x. This is denoted by small f, okay. While cumulative distribution function CDF is denoted in capital letters fx of x, this is denoted in small letters. So fx of x, which is denoted by small fx, this is the probability distribution function, and cumulative distribution function is represented by capital Fx of x, is always greater than 0. Integral of fx of x dx between minus infinity to infinity is 1, and between two other points a and b both positive, you get that to be the probability of what? Probability of x between a and b. Is that clear? Next properties, p of x element of a is equal to, in a particular area, is equal to integral a fx of x. And the fifth property is very important property that connects CDF with PDF. You know that fx of x is equal to d fx of x by dx. Now from this, if you calculate this fx of x, you will get fx of x to be the integral value of fx u du between minus infinity and infinity. Now how will you draw this PDF for this function and CDF for this function? How will you draw the PDF and CDF for this function? We'll come to this problem after we study what is statistical averages, because we are expected to calculate the statistical average also. Now let us take the sample space. Sample space for this particular experiment, random experiment, will be all values between 1 to 6. Okay. Event 1 is omega 1, which is when 6 falls. Event 2 is when 3 or 4 falls. Event 3 is when 5 falls. And event 4 is when 1 or 2 falls. You are having a die, you are throwing it, and we are dividing this question into mathematical equation where we have defined what is the sample space at the beginning, and we have defined all the 4 events W1, W2, W3 and W4. So let us start with statistical averages. The expected value of a random variable x. Expected value e of x is defined as the integral minus infinity to infinity x into fx of x. That is the probability distribution function of x. We will be using statistical averages for so many problems that is coming up. Mean and variance of a random variable. Expected value e of x is defined as minus infinity to infinity x of x. Now, mean mu of x is defined as e of x, that is expected value of x between minus infinity to infinity, or the sum of all values of the probability of individual values. What is the mean of a random variable? What is meant by variance of a random variable? Variance of a random variable is an estimate of the spread of probability distribution about the mean. The word variance itself gives you a hint that what is meant by variance. Variance is an estimate about the spread, how much it is getting extended over the mean. So mean is the statistical average. Mean means the center point, right? Variance sigma x is given by the expectation of the square distance of the outcome of the mean value of the distribution. Sigma x square is equal to e of x minus mu x the whole square, where mu x is the mean of the variable. Otherwise, sum of all values in x, x minus mu x the whole square into p, x minus x is equal to x. You may very commonly get questions to find the mean and variance of a random variable. We will be doing some problems. The remaining problems I'll give you as assignments and you have to do it. Let us consider x as a random variable representing the voltage of a random signal. The variance represents the AC power of the signal. I am trying to explain what is meant by mean and variance using an analogy. Let us consider x to be a random variable that represents the observations of a voltage in a random signal, and we will be expecting that you will have an average, right, x. So the variance will determine the AC power of the signal. Why power? Because it is squared. The second moment x ex square is also called the mean square value of the random signal, and it physically represents the total power of the signal. And you may get questions to find out the AC power of a signal. That means that you need to calculate its variance. So let us define what is meant by covariance of two random variables. Here we have two random variables x and y given by the expected value of the product of two random variables. The covariance of two random variables x and y is given by the expected value of the product of two random variables. Covariance x is equal to x minus mu x, expected value e of x minus mu x into y minus mu y. So thank you all for listening to me.